Hello everyone, welcome back to my channel. This is a three-part series in the regression diagnostics. Just in case if you haven't yet gotten a chance to review my previous video, which is a slideshow explaining how I would do the regression diagnostics and the vital things required to run a regression analysis. Please go back and watch that video in order to get a better understanding of this regression diagnostics and where it stands in the entire process. So I already had this data. The variables are average age, proportion of Black patients, type of payment made, is it Medicaid or Medicare, the average activity of the patient's activity score, average daily activity, and the total number of beds in the nursing home, and then the status of the nursing home. It is a binary variable. 1 is for profit and 0 is not for profit. Now, the first thing you would do for any data you have at hand is ask a question depending on the variables you have in your data. I'm asking a question that is there an association between type of nursing home and average daily activity? Pay attention to the word association because I'm not doing a causal relationship. I'm just doing a correlational analysis. So if it were to be a causal relationship, you would be asking, is there any effect between the type of nursing home and average daily activity of the patients in the nursing home? In this regression diagnostics, the basic things we would be checking is there a correct functional form presence for the form of the expected means? Is there homoscedasticity? Is there a distributional assumption of residuals? And finally, is there an independence of error term? And majority of these fall in the specification analysis, which I'll show in part 3 of this video series. By doing a regression diagnostic, we are basically checking if there is a violation of any of the regression assumptions. So the vital step, the first step in any regression analysis or regression diagnostics is to do a data summary statistics. What does that mean is you have to summarize, describe, and tabulate your data along with, if you want, if you're like doing an advanced project and need graphs, then you can plot the k-density plots or the p-norm and q-norm plots. For now, and I'll also be showing additional commands which you could run if you have like a full-blown project which needs descriptive analysis. So for the first step, you can do this, which is an easy step. You can provide a global y list and x list to your variables in the data. So in my question, my y, which is an outcome variable, is average daily activity, and my independent variable or the primary variable predictor is the type of nursing home. So now if you see my global list, I have given a y list for average daily activity. This is the variable in my data. And then I'm giving an x list to the key independent variable and then the rest of the covariates I anticipate analyzing. So we first run these commands. Then the next step is to describe the variables of interest. So I would describe the variables. It would show you the storage type, which in other words means if your variable is a categorical or is your variable an integer or is it a continuous variable. And then you run a summarize. So the key important point to note here is summarize makes sense. The summarize command makes sense only for the continuous variables, not for the categorical variables. So let's just say what I mean. In other words, is let's just say for profit, the mean is 0.68. This doesn't make any sense because it's a binary variable. 1 is the nursing home is for profit, and 0, which is coded as they are not for profit. So in order for you to get a sensible descriptive analysis for your categorical variable, you have to run a tabulate command. The reason I did a Y list and X list is I just didn't want it to separate the outcome variables, the categorical and continuous. I might as well just like not interpret those commands in the data and then later run a tabulate command. So on summarize, I could see the average score of daily activity is about 16 points in my data, and the average age is about 80 years, and then average total number of beds, the mean total number of beds in the nursing home are about 106 total beds. Now for my categorical variable, I wouldn't be running this. I mean, you can run if it suits, and if you will, like if you want to know in depth how many observations are in your data for a specific continuous variable, then you can run a tabulate command. For now, so there are, if you see for profit variable, you could see there are about 4,900 not-for-profit nursing homes in the data and about 10,000 for-profit. So the following commands gives you a detail of percentile, quartiles, in other words, the smallest and the largest value in your data, and then skewness and kurtosis values as well. To keep in mind, you can use these for, as I said before, the summarize command is only, it makes sense for continuous variables. So let's say if I summarize and use the detail command, you get these results. How to interpret this table is you go by columns and not by rows. So the first column is percentile, which means about 25% of people in my data have a score of 14 below 25%. Then people with a score of 16 in my data for average daily activity fall below 50%, and then 75%, and so on and so forth. The smallest value of average daily activity in my data is 0, and the largest value is about 28. It also shows you how many total number of observations are in your data. I have about 15,000 observations in my data. The mean score of my outcome variable, which is average daily activity, the mean is about 16. It also gives you standard deviation of the variable, and then skewness, kurtosis, and variance in the data. Now the following commands are optional. If you want to run it, you can run it. If I'm not doing a full-blown project and I just want to do a basic descriptive analysis, the previous commands which I showed are enough. But if you want to do a two-way table, or I'm not going to run these because it's a huge data for my computer to take, so it will take a while to take a manipulation. But you can feel free to use any of these tabs that gives you summary statistics. It would give you total number of counts, means, skewness, kurtosis, so on and so forth. Now, what I would suggest running are the plots. So these are the key. You can run a k-density plot, or you can run p-norm and q-norm plots. In